Hello everyone, so this is my starscapes presentation on display and image processing. So these are some of the topics we'll be discussing today. Um, these topics are over chapter 15 in our instrumentation book for physics. We're not going to go over every single thing that is covered in chapter 15. I just wanted to touch on some of the image processing components and how we optimize our images. So we will be discussing pre and post processing functions, coded excitation, packs, and DICOM. So I just thought it was kind of cool and wanted to mention how we optimize our images and how we take images are very different from when ultrasound first started. Nowadays, they are developing technology where we can start scanning on mobile devices, whether it's iPad or a phone, tablet, or just a portable computer. And they're even building technology where you can have a wireless transducer. So ultrasound has come really far and is constantly changing throughout the years. So let's get into some pre-processing functions on our machines. So we have right magnification, spatial compounding, edge enhancement, and fill-in interpolation. These are all pre-processing functions. So before the image is fully saved. So right magnification, this occurs when the image is still live. So basically, this is before we have frozen the image and saved it. We are live scanning, moving our transducer around. With right magnification, this is where we zoom in on a specific area or an area of interest. Then the machine will send down all scan lines and use all pixels to create a better spatial resolution or detail resolution. So we're getting the best resolution of this image using all pixels, all scan lines. So the pixels don't get any bigger, and the machine sends more scan lines down and creates a better image before we freeze. So the next pre-processing function is spatial compounding. There are three different types of compounding, but we'll be discussing spatial compounding for our pre-processing functions. So we typically, with spatial compounding, use a linear transducer. And when the spatial compounding setting is turned on, it averages multiple frames taken from all different angles to create a better overall image. So basically it's taking it from multiple angles and compounding and averaging it into one image. So this improves our spatial resolution or detail resolution like we talked about in the last slide, but it degrades temporal resolution. And temporal resolution is our time, our frame rate, and it slows this down, so it makes it a little more laggy. So to conclude spatial compounding, we average multiple different angles into one image to improve our detail of our image, but it will degrade our temporal resolution, slow the image down. Another pre-processing function is edge enhancement. So edge enhancement is basically where the machine recognizes borders of structures and puts a highlight and low light between these borders to improve contrast resolution and make the image sharper. This helps us get more detail on borders of pathology, organs, all the good stuff. So the last pre-processing function we will be discussing is fill-in interpolation. So fill-in interpolation predicts the missing grays in between scan lines. So basically with a curved linear array, for example, the scan lines are a lot closer together, and the further you go into the body, the more the scan lines separate. This leaves missing information in between scan lines, so fill-in interpolation will fill in those missing grays in between those scan lines the deeper we go into the body. This also improves temporal resolution by reducing the need for sending down more scan lines. So instead of sending more scan lines down, making the picture lag even more, it just fills in those missing pieces, therefore making temporal resolution better and less laggy. Alright, so now we will be discussing some post-processing functions. So with post-processing functions, basically post-processing functions have anything to do with a frozen image. So any changes to a frozen image. So when we freeze, we can adjust gain, zoom, etc. I mean, only on some machines. Most of our modern machines, post-processing, we can change the gain and zoom and all of that. Then we have read magnification as a post-processing function and 3D rendering. Alright, so read magnification. Read magnification is different from write magnification because it is after we hit the freeze button. So this is when we freeze an image and we zoom into something with our zoom box or just the zoom toggle, and we hone in on something after we have already stored the image. So with this, the pixels do get larger versus the write magnification where it does not. So this decreases our resolution. So resolution, or our detail, is reduced when we zoom in on a specific area after we have already frozen and stored the image. Another post-processing function is coded excitation. Alright, so with coded excitation, it improves the image quality by sending a longer pulse with little sharp pulses called chirps. These little chirps along the long pulse are like little codes that capture little pieces of detail that maybe a longer continuous pulse might not get. This function is produced by the pulsar or the beamformer in our transducer. It improves axial, spatial, and contrast resolution. So this gives us a lot more detail here, but it also creates a higher signal to noise ratio. So it helps us ignore a lot of that noise in the surrounding image, and it helps us with deeper penetration so we can see even further into the body. So there's a lot of benefits with coded excitation for post-processing. And lastly, we have 3D rendering as a post-processing function. This is a newer feature in ultrasound. This function adds all 3 scan planes into one image, but it is manipulated after the image is taken. And this 3D image can be manually scanned in all 3 scan planes or automatically done by our transducer. But because the 3D image is manipulated after the image is taken, this makes it a post-processing function. And as you can see here in the example, there's 2D image, 3D image. There's actually 4D and 5D that is becoming more popular and new with newer machines. Alright, and lastly, we'll just briefly touch on PACS and DICOM. PACS is our picture archiving and communication system. This is just a system where images and medical information is digitized and stored in a large network or computer that most all hospitals can reach. And it allows instantaneous access to archived medical records. DICOM is digital imaging and computers in medicine. It's just a set of rules for medical imaging that is broadly used over a lot of different systems. It allows for better communication and access to images across all networks, and it is typically stored in PACS. And these are my resources. Thanks, everyone.